This is the ugly intro slide. We'll get to a nice intro slide in a second. Anyway, I'm going to introduce myself first. My name is Kurt. I am a founder of a company called Fly.io. We're building a programmable CDN and doing a lot of really somewhat amazing, somewhat awful things with Redis. My last company was called Compose, and we actually hosted Redis for developers and watched them do some amazing and some awful things with Redis. God, every time. And then before that, I worked for a site called Ars Technica at Condé Nast, basically trying to make things fast, which is again, Redis. And this was, I think, the very first time I ever installed Redis was like 2008. So it was like 0.0, probably didn't work. And so I've been doing things with Redis for a long time and trying to solve a lot of strange problems with it. So yeah, that's me. The actual talk is a romantic comedy, and so. It's interesting because I don't like romantic comedies, but I think like the structure is really fascinating because you have this entire cycle of me like intense, strong feelings for a person or database engine. It works really well as like the honeymoon period, and then something happens, and then yeah. Anyway, there's spoilers right for the talk, but romantic comedies is just this funny structure for telling you our trials and tribulations with Redis this time around. And plus we have an amazing artist who gives me cool slides, so I basically just have to talk over whatever she colors for me. So basically what we're going to talk about is Fly.io, which is a single kind of cool startup looking for like global data problems at speed, and with wormy arms and a big muscle. And what we're looking for is like a really like adventurous, low maintenance persistence engine that's also really into speed, right? And probably doesn't forget things. These are kind of like the two big problems we want to solve here. And all that is to say is we're running a CDN, and a CDN is servers all over the world. And we're actually running a programmable CDN, which means we want to give developers the ability to write JavaScript to make it do things that we didn't ever imagine. And one of the big things a CDN has to do is it has to cache data, and it has to cache data very quickly. And then the other thing is we need to distribute configuration. So these are kind of like the two big problems that we care about. And I can get into more of what the company does in a little bit, but I'll kind of talk about the problems we tried to solve, how we maybe tried to solve them, what didn't go so well. So obviously we're seeking Redis. Again, spoiler, right? Like we fall in love with Redis. And it's kind of an amazing little story, right? Like we want to do some very complicated sounding things. Like running one distributed database across the world is actually a difficult problem. It's a hard thing to think about. There's things like CockroachDB and and you can run a global Cassandra if you hate yourself. There's these amazing ways to run very difficult databases across the internet. And one of the things that we really liked about Redis was obviously that it's super fast, right? If you do most stuff with geodata, it's slow for a lot of the things that we need to solve. So caching in particular, we don't particularly care if like the same data is in Chicago as in Sydney when you make a request to Chicago. We don't really have that kind of consistency problem on caching. But a lot of the existing geodatabases assume that you care less about speed than consistency. And so speed matters to us a lot. And what we actually need is really fast, and we need to be consistently fast. We can't have things where it's like, well, it's mostly fast, but 2% of the time it's 1,000 times slower, which is, again, Cassandra. This is how Cassandra treats you. And so obviously Redis is great. We've had this history of broken database relationships. Redis is great at speed. It's always fast. It's amazing. That's not quite true, but it feels this way at the beginning, right? So and I know we all love Redis benchmarks. These are just straight off the Redis wiki. The point is it's fast. The other thing is, one of my favorite things about Redis is the replication model. And as a caveat here, Redis calls things master-slave, which I'm not super happy to say out loud, but it's also not like the best description of what's actually happening. Redis's replication model is backwards from most databases. When you set up a cluster, like a Postgres or a Mongo cluster, and you want to have a primary and a secondary, right? Usually what happens is you go tell the primary, like, here's the secondaries you should care about, like, go take them over. Redis is cool because you set up a cluster, and then you set up all of these sort of secondary nodes all over, and you just say, look, there's the source of data you care about, and you don't have to worry about the whole cluster. It's actually really perfect for the config store option I was talking about a minute ago. We have servers all over the world, but what happens when people want to write configuration data is they want to write it one place, they want it to come back very quickly, and they want it to propagate as quickly as possible out. And so all we really had to do was we set up a primary Redis cluster, and then we set up Redis secondaries on all of our servers, which was awesome, right? Like, it's great. This is, again, amazing, you know, urban New York love story still. The other cool thing is secondary writes, and this is not the default in Redis anymore, but prior to Redis 4, you could just write to your secondaries. It didn't matter if it was replicating from something, you could just write to it, and it would trust that you either knew what you were doing or you really didn't care about screwing up your data consistency. Redis 4 made that, it's probably safe to be off by default, but it's an optional thing. And what's really cool about being able to write to all these globally distributed secondaries is we can do things like distribute encrypted certificates that, like, we use Amazon's KMS to decrypt, which is really slow. So what we actually do is we distribute the encrypted certificate. Each node, the first time it decrypts it, it writes the decrypted block or the decrypted certificate right back into the secondary. So the next lookup is very quick. And the neat thing is as soon as the primary gets a new copy of the certificate, it blows away our happily unencrypted one. So it's a little bit consistent because we always get the most fresh data. It's just that sometimes it's encrypted. And this was kind of mind-blowing because you end up with a lot less moving pieces when you can just read from the same thing you're using for caching. It's like, this is one of my favorite things to do with Redis. And again, this is great for caching and to config things. Probably not something you want to do all the time. So like most romantic comedies, the honeymoon is over at some point. And a lot of the reason for this is a lot of times it's mistaken expectations. A lot of times it's like you've kind of grown differently from the person. And it just generally ends up with anger and self-loathing. And this is, again, like every database. So our very first period of betrayal was, and this became especially apparent, the Redis backlog size controls how long a secondary can be stale before it just does an entire resync, incidentally becoming unavailable for anything that tries to read from it. And the default Redis backlog size is 1 megabyte. So if you have a primary in Chicago, like we do, if you have a secondary in Sydney, like you do, and then a megabyte of data changes on the primary and doesn't get replicated quickly enough to Sydney, then it basically reboots the entire thing, resyncs however much data you have in there, which tends to be a lot, and just makes everything not work for a little bit. It was stunning when this happened, right? I didn't like it. It wasn't fun. We had some downtime. We had to go fix this. But again, like most relationship issues, really what this was our needs changing and the underlying database didn't, right? In most fights I've ever been in with my wife have not been because she did something different. It's been because like I either got more complicated or did something different. So Redis is the same. The other fun problem is like RAM is really freaking expensive. So our very naive first caching solution was, all right, cool, we have our primary, we'll just write to that and let it replicate everywhere, which is great until you're running 52 servers with 64 gigs of RAM each with all the same copies of data in it. It was kind of a terrible thing. And part of the solution to this is you just don't keep big files in Redis, which turns out, I apologize to the Redis Labs people here. If you try and buy Redis Labs to solve this problem, and they have a cool feature for this called Redis Flash, which lets you do like, it lets you overflow to disk effectively, and so you can make a lookup. It actually would have cost us $1 million a month to solve this problem with money, which is even somehow more expensive than RAM. It's just because their pricing model is not meant for what we're doing, but like RAM is frigging expensive. And this is one of those things that's like, yeah, we kind of knew this. It was a problem we knew and just ignored really early on, which happens in most relationships. Other fun problem for our use case specifically is nothing in Redis is encrypted. The protocol is not encrypted. None of the drivers talk to servers over an encrypted connection, and the secondaries don't sync encrypted, which is like not a great thing if you're going from we have a server in Hong Kong that's syncing back to Chicago, and there's a lot of opportunity in there for someone to see the traffic going through. This one's a little bit artificial. We knew this. It wasn't like a big shocker, but it's a fun angry slide. So this is but that's a big problem, right? So like this is what happens when you dump all your expectations and all your needs on another thing or person or database. So really what we got to is this spiral of despair, and it's really because we were codependent. Like in every broken relationship, there's usually some level of codependency, which is really like, I have all these problems, please solve them for me. It's like, I don't really want to do anything, I just want you to fix all this shit for me. And this was really kind of where we got to with Redis as we were having these issues, having our drama. It's funny because if you read the internet, you actually see this pattern a lot with developers. You'll see, hey, how we migrated off Mongo to DynamoDB, and everything is so much better now. And the reality is like what happened is you actually just put work into your new relationship and you didn't really bother with the old relationship. So this is a thing that we've all experienced. This is a thing we saw people experience at Compose. But the reality is like, it's really fun to look at a thing like Redis and be like, you're wrong, you're not doing the right things for me anymore, and that's not always true. Like, it pays to be a little introspective. Because what happens in the future is you come back across this thing that you like had this hot, passionate relationship with that went south, and it becomes like, it's like, hey, you're kind of the perfect thing for this problem I have. It might be getting coffee, or in our case, it might be, we have this really complicated caching problem where if you've used a CDN, one of the kind of the minimum features of a CDN at this point is I have images cached all over the world. I want to expire one of them, and I want the expiration to happen in human terms immediately. So like it can take however many milliseconds light takes to travel. But the reality is like I want to cache things and I want to get rid of them immediately because I might get sued otherwise. And so this was our problem. This was like, all right, cool, how do we solve this? And one of the interesting things about geocaching is if I publish a blog post, or I publish a lot of blog posts, the things that get cached are not actually global. You'll see a lot of different data in Chicago and Amsterdam and Hong Kong, for example. But you might see redundancy. So what you really need to be able to do is propagate this, nuke this from the cache message to everything. And so this is our chance encounter with Redis, because Redis has some amazing primitives for both publishing notifications like that and then also keeping the new copy in sync. And what we ended up implementing was this neat thing where we expire a key, or we expire a dependent key, and then we immediately publish that message out to everyone who's connected. But since everyone may not be connected that particular day, the secondaries, we actually, we just write the expirations into a sorted set as well. So if you use the zset command in Redis, all we do is we write key, timestamp, and then when the secondary comes back online, we know that it needs to go through and clean up after itself based on sort of this pseudo transaction log that's just happened. And this is a cool thing, like this would be super complicated with most databases. This is a difficult problem to solve in like a scalable, not super expensive way, like Cassandra again. So this was our like, oh, well, maybe this relationship's worth putting some more time into. And so we gave it a shot, and we decided to like, you know, see what else we could make Redis do for us and where else it fit. Because it has, like I said, all these good primitives for things like pub/sub, but it has all these flaws, which aren't exactly flaws, they're just, they don't fit quite for what we need to be doing. So again, this is like happy, you know, this is pre-kid, so everyone's still smiling, part of our relationship here. I have 4 kids, I can say that. So this is the opposite of codependence, is a word no one's ever heard of, but it's interdependence. It's like, hey, cool, you know what, this is a worthy, committed relationship. You're gonna do good things for us. I'm gonna put the effort in to make this work really well for us. And here's kind of some of what we came up with. And these slides, like, so each of these slides is probably an entire talk by itself. This is gonna be a little superficial, but basically what I'm gonna do is I'm gonna end this in like 10 minutes, and if you guys have questions, talk about what you want. And if you don't have questions, I'll be ashamed. So I'm gonna end this, and then like I encourage you all to ask, like I'm happy to show you code examples or config examples or all these things. But like I said, each one of these is actually kind of a huge thing all by itself. So the very first thing we did is like, well, we need to have more reasonable expectations from the database engine. And one of the things that makes Redis so neat is it's incredibly focused. It doesn't have, like, it makes sense that it doesn't have an encrypted protocol, because if you put OpenSSL in something, you've just created a whole bunch of other problems for yourself. Like it's like you don't want to expand the Redis surface area that much. And what's cool these days is we have very neat tools for encrypting connections between servers that abstract this problem away. So one of the things I would suggest looking at if you care about encrypting the transit between Redis is WireGuard. WireGuard lets you set up a an encrypted tunnel between two servers. And this is not like I have to install a VPN server and I need kernel level access to the drivers. This is like really, really, really easy to set up. So all our Redis talks over WireGuard, and we actually have kind of a lot. Like depending on which ones are replicating with each other, we can maintain 50 or 60 WireGuard connections per server with no issues. It's just a really, really nice lower level way of solving this encryption problem. In fact, we've started using this for a lot more of our application because it's like building SSL or any kind of encrypting into any kind of inter-application communication is really complicated. So the real big takeaway from this slide and the entire talk by itself is use WireGuard because WireGuard is awesome. The other big reasonable thing we've decided is like maybe we just shouldn't put everything in Redis. And so we've started looking at Redis for caching as mostly a metadata store. So we'll keep like a global index of files we have cached with like hashes with whichever blob they're stored on whichever server. And it's sort of consistent. So one of the interesting things about keeping things in two places is we can have metadata in Redis and the file can just vanish. Or we can have a file somewhere and there might not be any metadata in Redis for it. And this is like, fine, this is a problem we have to figure out. It's relatively easy to do, and this goes back to Redis's speed. It's basically cheap to do a lookup in Redis, so we might as well. It's not really costing us anything to do that. And so this is so like, if I were trying to replicate this at home for my own app, what I might actually do is keep an index of all my S3 stuff, if you're using AWS or whatever Google calls theirs. I might keep all of that in Redis, actually keep the stuff in S3, and then make sure like use the TTLs. Redis lets you set keys to expire at a certain time. Most good object storage places let you set keys to expire at a certain time. You can keep those mostly the same. Like you don't really have to worry about if things actually vanish at exactly the same time for caching purposes, because you can always go get it back, which is sort of the other portion of how we use Redis. Redis is really not our canonical data store for anything. Even like the config data we distribute is in a Postgres database, and then we serialize it and put it in Redis in a way that's really, really fast to look up. Or the encrypted bits, like we don't necessarily keep the encrypted keys just in Redis because that is just not the greatest idea for it. And it's nice to have disposable stuff. So, the other big thing we did is we looked at, there's actually a lot of different tools like this. So if you've heard of like TWIM proxy or Netflix is called Dynamo, weirdly. And there's another one, there's a Go-based version of this. And what these are Redis proxies that abstract the cluster behind them. And Dynamo from Netflix is like most of their projects. Netflix has these amazing open source products that are impossible to use. So we actually managed to get Dynamo working. It works really well for us. It lets us do really interesting things like within a data center, we don't want to replicate our cache data, so we can shard across however many servers we have running. But across data centers, we want our config data to be replicated, so we can actually replicate across all the data centers, but keep them only on one host per data center, and actually get very consistent writes from Dynamo. And this was actually, if we'd had this working in time, that's what this whole talk would have been about. But this is like a week old for us, so I don't actually have enough content for a talk on it. But I would definitely look into Dynamo if you're trying to do interesting things with Redis. One of the things I dislike about Redis is like the replication model is amazing, but I don't particularly love the clustering model. I don't particularly love the sentinels and failover model. I don't want the app servers to know the layout of my database. I just want them to get a URL to look at, and Dynamo gives you that. And that was 20 minutes, so this is 26 minutes left for questions. But first I'm gonna shill for our company a little bit. So you should actually check out our company. We're hiring. If you like working on distributed data problems or embedded JavaScript runtimes or anything that is trying to like get around the really slow speed of light, we're doing some really cool stuff. And if you've ever used a CDN and run into a feature that you don't know how to, that doesn't quite work the way you want it to, then you should come check us out and write a little bit of JavaScript to do it for you. You can do things like caching, which is what we talked about a lot. You can pre-render React, you can optimize images, and it's open source, so that's cool. And you can download it and run it locally, run tests, all that stuff. So, second thank you slide, and either we can answer questions for a bit, or yes. I'll repeat it, you can just say it. Yep. So the question is in the case of a network partition, which everybody's probably experienced, even if you didn't know it, is basically like, I think the question is like, how do we handle that, or what tools kind of does Redis give you for Yeah, so the Dynamo thing I talked about in the last slide, Netflix's thing, is actually, it's really consistent. So it can handle, I'm not sure there's been a Call Me Maybe about it. If anyone, Call Me Maybe is a series of articles, Jepson, a series of articles a guy named Kyle Kingsbury wrote that tests consistency on databases. I don't know if he's tested Dynamo, but in theory, if you care that much about consistency, you should write through something like Dynamo. The Redis replication model is eventually consistent, so there are ways to to verify that your writes have propagated to the secondaries. For the most part, the way we solve this problem is we don't worry so much about consistency. What we actually monitor is the replication lag on each secondary. So we want to make sure that the replication, we want to make sure that the secondary is, well, A, not farther behind than our backlog size, but also like that's a big indicator of health for us, is like if a secondary is 10 minutes behind all of a sudden, that's a problem. But since it's syncing from a primary, we can just fix that. We don't actually, it's like most of our problems are eventually consistent. So we don't suffer from network partitions quite the same as you would if you were using it for like your Postgres replacement. But in general, like most of what we solve is just by knowing what the consistency is like and understanding how to adapt to it. But Dynamo definitely solves that problem if you need high consistency. All right, other questions? Keep asking, please. Next 5 questions get a T-shirt I forgot to bring.
Compared to Redis running in master-slave mode,
yep.
How do you compare, how stable is the cluster mode compared to the master-slave mode?
Well, so like the Redis, so there's 2 kinds. The Redis clustering, we haven't actually investigated that much because it's not right for our geo problem. Sorry. The Redis actual, and when I mean clustering, I mean their horizontal scalability. So like Redis clustering is designed to run in the one data center. It's not meant to be used across the world like this. So there's no concept that I'm aware of. Like I haven't really looked at this in like 6 months. There's no concept I'm aware of in Redis cluster that lets you say this range of data belongs to Chicago and this range of data belongs to Frankfurt. Which is really what we needed. So we just didn't, now for the actual replication clusters, the redundant clusters, that's if you've ever set up a Redis cluster for failover, what you end up doing is you run at least 2 Redis nodes. You have the primary and the secondary, then you run 3 sentinels alongside it, which basically vote on who's in charge at any given time. And then your drivers need to be aware of the sentinels, and what they actually do is subscribe notifications from the sentinels. And when your primary falls over, the sentinels will elect a new primary, and then your driver has to know to reconnect, which is just, that's like, it actually works really well, and it's probably the simplest way to get really consistent failover. It's just like, it's really complicated for the application to care about that. And for our purposes, we just didn't, like I said, we want one like connection string to use for everything. We don't particularly want to be connecting to 5 different Redis processes for each. Well, yes, the clustering, Redis clustering is not designed to run in multiple geographies. So like you can run one on like AWS availability zones in US East are different data centers. And it works pretty well for that because it's relatively low latency between those. But if you go from like San Francisco to New York, like I think the best possible latency is like 80 milliseconds at that point. That Redis clustering is not great for that because what you end up having is I want to make a request for a particular key without any kind of intelligence about where in the world that key is located. So if you could do like a simple Redis get that ends up taking 80 milliseconds if you try and run a cluster across the world, which is painful. Good?
Have you guys had any experience with using EV cache in doing active-active replication?
Sorry, using what?
EV cache.
EV cache is?
Netflix's.
I don't, like I don't. That sounds vaguely familiar, but we don't have any experience with it.
Okay. They do active-active replication, like if you have a Redis cluster in US West, you have a Redis cluster in US East. So you basically, their client basically writes into a proxy, and then this EV cache sets up a...
So that's what we are using Dynamo for, which is also Netflix. because they have competing groups for these things, I guess. So Dynamo, it doesn't replicate between the regions, or it doesn't replicate between the clusters, but it actually propagates writes out, which I think is what you're describing from their other project.
So is it just like the client? Dynamo is a client that basically writes into all the clusters?
Yeah, so our drivers connect to Dynamo, which actually manages all of the underlying Redis instances, and it'll do things like if we make a write that needs to replicate 3 times, it'll write to the 3 nodes it's supposed to, and it won't confirm to us until the write's done. So I think it serves a similar purpose as what you're talking about, but we haven't looked at EV cache, I think. Yes, so you can actually, well, it's configurable. So like for our config data, what we actually want, depending on what you're writing, is we want it mostly synchronous. So like if you write to US East, we might want it to go to New York and Chicago as well before it returns, but we don't necessarily want to wait on Sydney. So you have some ability to control, yeah, exactly, per write. And the question there was do you pay the write penalty if it's propagating writes all over the world? And the simple answer is like it's highly flexible and highly configurable in a way that like Redis clustering is not. Cool, cool.
This is a very specific question, but on one of your slides, you talked about replication backlog size.
Yes.
And I was wondering why the unit is like not time-based. You said like the secondary would get out of sync with the primary,
Right.
and then it would be overwritten or something. So I guess I just don't really understand this config variable and how it works.
So the question you're actually asking is, I think, why we had problems with this config, which is it's not time-based. All it is like a fixed unit of data. And so all this really looks at is the secondary says, I'm going to connect to the primary. If I discover I'm more than a megabyte behind, I'm just going to start from scratch and resync the whole thing. And in our case, like that megabyte could actually happen in 500 milliseconds. It's a very small window of time for that much data to be written. So but the trade-off, I think, is that it needs to keep a lot more of the write log in memory. So like if you put this at a gig, you're basically setting aside a gigabyte of memory for the secondaries to be able to catch up with, but it's still not time-based. Like in theory, you could still write that faster than like your secondaries can read from it. Does that answer your question?
Yeah, that makes sense. Thank you.
Sorry, just a follow-up question on her question. Is this replication backlog regarding the Redis replication between master and the replica?
Yes.
Or regarding Dynamo?
This is not Dynamo.
Just to be clear.
Yes, this is so Dynamo replicates differently.
Synchronously, right?
Synchronously, right. Yes, this is the Redis built-in replication backlog.
Okay.
And this is the default Redis setting, which is a thing that you should change immediately.
So as far as you were saying, because you guys are using Dynamo now, we are leaning towards not using this replication mechanism anymore,
well,
or it's depending on your use case?
It depends on, we actually have logically 3 Redis clusters running that do 3 different things. And so Redis replications, despite like me complaining about this setting, Redis replication is amazing for a lot of stuff. So I suspect we'll always use it. But for things where we are more concerned about consistency, like I think the real question is do you care about write consistency or kind of ease of use and flexibility? So if the ease of use and flexibility matters more than write consistency, Redis replication is great. If you need write consistency, particularly across geographies, then something like Dynamo is a better choice. But we'll definitely always use this with our much higher backlog size.
Is it because of your size of your objects that you store in Redis?
Like
you can set an image?
Yeah, it was a little bit of that. We can have objects that are like 10 megabytes, which is definitely a problem for this. But at the same time, this is a function of scale. You're going to set this, if you're us, you set a cluster up like this, like, cool, this is great. This is working really well for my one app. And then you get people actually using it, and it's not just the size of the data. It's actually like how many commands are you piping through in any given instance.
Okay, thanks.
Do you want the microphone? You want me to repeat your question? Okay.
I think you just answered this, but you guys don't do any sharding, do you?
So we don't, we do. And the way we do this is where Dynamo's neat. So what we do, Dynamo's great for sharding Redis the way we need to. And what we actually need I take that back. Dynamo's mostly great for sharding Redis the way we need to. What we want to do, especially for cache, is like it doesn't make a lot of sense to replicate cache data because it's rebuildable, and like we're more concerned about how much people. This is backwards, right? We make more money if we charge more, but we're more concerned about not charging people for redundant memory effectively. So Dynamo lets us, in a given data center, it lets us turn 2 or 10 or 20 Redis boxes into one logical sharded cluster, where if one goes away, we don't really care because we can just go rebuild that data. Cool. Good questions. I'm not kidding about t-shirts. If anyone wants a t-shirt, you should email us. I just forgot to bring them. We have cool balloon logos.
You mentioned Jasmine, and I read his article about Redis. He was very critical about the replication mechanism. Have you seen Antire's response was theoretically yes, but real life never. Have you seen any of his issues about consistency and missing master acts and all of those things in real life?
So we haven't, but at Compose, we definitely saw people do stupid stuff with Redis that might have been Redis with consistency issues, but it's like really hard to tell when a developer does something odd or the database engine does. So it's actually funny because the way we use Redis, we wouldn't come across that stuff because it's mostly eventually consistent. We tend to re-replicate things a lot, so for like a couple of minutes, there might be some inconsistency, but ultimately it'll resolve itself. But one of my, actually, as much as I like to make fun of the different terms in Redis, like Redis streams are neat, but they're not what I consider streams. It's like a slightly different word for a different concept. One of my favorite things about Redis, I think, is like, if you had a database nerd write Redis, it wouldn't be as good and as useful as it is now because there's so much database theory that it isn't. This is how you get, honestly, is how you get Cassandra. It's like Cassandra's great for some things, but for what Redis is great at, like I kind of love this whole like, well, in the real world, this is not that big a deal for the way people use Redis. Like I actually really like that answer, so I'm glad you asked that because I got to share an opinion. All right. Anything else? Well, again, thank you all for coming. I will go put up their thank you slide now. And I hope you enjoyed the little corner and the rom-com jokes. And like I said, feel free to email or ask questions.